It's the holiday season again. Not too long ago we had Halloween, followed by Thanksgiving. Just a couple days ago we had Christmas, and at the end of this week, it'll be New Year's Eve and New Year's Day. The holidays are, for many, often a staple of being with family and sweet indulgences. But I'm pretty sure that all of us have had experiences with a sugar stomachache, one that results from eating too much of those sweet delights. But what is the actual science behind that? And why is it that sugar can cause us stomach pain? Well, let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello, all you scientists out there, and welcome on back. As you heard from the intro, we're going to be talking about sugar today. And now, ladies and gentlemen, before we get into today's episode, I want to invite all of you to go grab yourselves a nice steaming hot cup of coffee and add just a little bit of maple syrup in there for that kick, for those autumn flavors, and for that pizzazz that you expect every day in your morning cup of coffee. Now, before we get started in today's episode, I would like to say, for all of my new listeners out there, because I know there are a lot of you, in a previous episode, Season 1, Episode 4, I talked about the intricacies of maple syrup, specifically what it is, how it's made, but we also did talk about the basic biochemistry of sugars. I would definitely recommend you listen to that episode before you listen to this one, because we are going to, get a little more biochemistry-y on today's episode. I'm going to try and keep it short, which is going to be a trick, but I'm going to try and keep it short today. So, yeah, ladies and gentlemen, let us get started, and I hope all of you guys are having a fantastic Friday morning. I hope it's as beautiful wherever you guys are as it is here. Let's jump right into it. So sugar is a really interesting, group of molecules, because sugars are a large group of molecules that are called saccharides. Now you have monosaccharides, you have polysaccharides, you have disaccharides, you have trisaccharides. You have a lot of different types of sugars, and I think a lot of people, when somebody says sugar, they only think of the sugar that you put in your coffee, right? That is table sugar, which is a sugar called sucrose. Now, sucrose is composed of one subunit of glucose and one subunit of fructose. Or as we say in biochemistry, it's a disaccharide composed of a monomer of sucrose and a monomer of glucose and a monomer of fructose. But of course, sucrose is not the only sugar in existence. Glucose is a sugar and fructose is a sugar. They're just small sugars, right? And those sugars tend to make up other sugars. But in milk, you have a sugar called lactose, which is, again, a disaccharide of glucose and another type of sugar called galactose, which is kind of fun. I always think like galactose sounds like galaxy or something. I don't know, but it sounds cool to me. It's not very sweet, but it sounds cool to me. Then I think the thing that most people are surprised by is DNA is a sugar. Well, its backbone is made up of a sugar. Deoxyribulose is a sugar. And in RNA, ribulose is a sugar. So a sugar is any molecule, basically, that has at least one hexagonal structure of carbons and oxygens. So, for example, the glucose molecule, the formula is C6H12O6. 6 carbons, 12 hydrogens, 6 oxygens, right? Now, these carbons and oxygens are arranged into a hexagon, And that is what is characteristic of a sugar. I can't really think of any exceptions, but to be considered a saccharide, you have to have at least one hexagonal arrangement of carbons and oxygens. Now, that being said, sugars are all metabolized differently. And what we're going to be talking about on today's episode is like the sugar in candy or the sugar in, I don't know, what's another sweet thing? Like cinnamon rolls or something like that. I don't eat sugar, so I haven't eaten sugar in a long time. And at the end of today's episode, hopefully you guys will find out why. And those sugars, the sugars that we find in like pastries and candy and whatnot, some of it is sucrose, but most of it is either fructose or high fructose corn syrup. Now, what is high fructose corn syrup? High fructose corn syrup is just fructose. It's just highly concentrated fructose. Now, before we can understand why a lot of sugar makes us sick, we have to first understand the differences in the metabolic pathways of glucose and fructose, because there are big differences. Glucose goes down a long line of metabolism into eventually pyruvate and then ATP or carbon dioxide. That is the metabolism pathway. The key distinction here is that because fructose, it also produces pyruvate, but the difference is when glucose produces pyruvate, the pyruvate is not metabolized. And pyruvate is all you guys need to know for the sake of this episode is pyruvate is just a byproduct. It's a molecule that is the byproduct of glucose and fructose metabolism. It's one of the byproducts. But for glucose, it's the second to last byproduct. However, generally speaking, pyruvate is not further metabolized, right? So with glucose metabolism, glucose goes down the line of being converted to several intermediates. Once it's converted to pyruvate, that pyruvate is then used to produce ATP and carbon dioxide. But with fructose, that's not what happens. With fructose, what happens is the pyruvate can either produce ATP and carbon dioxide, or what happens more frequently is that the pyruvate in fructose metabolism goes on to produce lactate, glucose, or fatty acids. Because you can use pyruvate to produce glucose through a process called gluconeogenesis, which we're not going to talk about today. The important part in the fructose metabolism pathway is that fatty acids, right? That's important because fructose metabolism results in the ultimate production of one type of fatty acid, which is a compound called low-density lipoprotein. Sorry, I had to think about it for a minute. It's been a while since I've had to consciously think about that. But the byproduct of fructose pyruvate metabolism is low-density lipoprotein. Now, what is low-density lipoprotein? Low-density lipoprotein is bad cholesterol. So I'm sure all of you have heard of good cholesterol and bad cholesterol. Good cholesterol is called HDL, or high-density lipoprotein. And why is it good? Because high-density lipoprotein, it plays a role in the removal of low-density lipoprotein from your blood. That's the biggest thing it does. But two, it does not precipitate out of solution in blood. Low-density lipoprotein does. And so when low-density lipoprotein, or LDL, is in blood, when it's in blood suspension, it will precipitate out of blood and it will settle on the internal endothelium or the internal wall of your arteries and veins. And when it does that, we've talked about macrophages many times before on this podcast. Macrophages, which are a type of immune cell, come along and think that LDL is a pathogenic threat. And so what they do is they ingest that LDL. But when they ingest that LDL, they become something that is called a foam cell. And foam cells are immobile. And that is what a plaque is it's a buildup of those foam cells, which then causes a further immune response to attack those foam cells, all because of the LDL. So long story short, that's what fructose is metabolized to. Glucose is just ultimately, it's metabolized to pyruvate and ATP, right? Now, if we're talking about storage forms of fructose and glucose, as far as I know, fructose doesn't really have a good storage form because generally most of it is immediately burned upon ingestion. The closest thing we get to a storage form of glucose is producing LDL of fructose is to produce LDL from pyruvate in the fructose metabolism pathway. Glucose is converted, on the other hand, to a multimer structure of glucose called glycogen, and glycogen is good for you. So when you get sick because you're eating too much sweets, it has nothing to do with glucose, and I think that's a common misconception. It has nothing to do with glucose. It has everything to do with fructose. Fructose results in the production of an enzyme, it needs an enzyme called aldolase B to be metabolized, right? However, there is a current theory that says that the reason why we get sick when we eat a lot of sugar is because the body gets overwhelmed by the amount of fructose and cannot produce enough aldolase B to reduce the fructose. And our body doesn't like to have fructose lying around in the intestines. We do have fructose in other regions of our body that is naturally produced, but the intestines are not one of those places. And when you have a stomach ache, it's either coming from your stomach if it's like indigestion, or if it's just like that dull stomach ache pain, that's coming from the upper part of your small intestine. And when there is not enough enzyme being produced by the human body to reduce that fructose, it just sits there. And that will trigger a whole endocrine and nervous system cascade to be like, yo, there's a problem here. We have to slow down. Stop eating. Problem is, this pathway does not trigger the release of leptin, and leptin is hunger satiation pathway. So what the body does instead is it basically sends up a signal that says you're really nauseous. It's like our backup way of preventing somebody from ingesting food. Well, considering this, your next question is probably going to be, well, why is it that some people are really tolerant of sugar and others are not very tolerant of sugar? And ultimately, the answer to that is simply just the more exposure an individual has had to fructose, according to the leading theory, the more efficient their body is at producing those enzymes to catalyze the degradation of fructose. So, to summarize then, the reason why somebody gets sick after eating too much fructose is most likely because they have reached almost a saturation point where it's just too much for their body to handle, and their body isn't producing enough of the required enzymes to break down the fructose. And so as a result, the fructose kind of pools in the upper regions of the smaller intestine, which then stimulates the chemoreceptors within that area of the body that, hey, there's too much fructose here. But because fructose itself inhibits the release of leptin, then you have to use other mechanisms to stop the consumption of more fructose, which results in the feelings of being sick and having a stomach ache. So, ladies and gentlemen, thank you very much for listening to today's episode. I hope you enjoyed today's episode. And I hope you guys have a wonderful Friday. This weekend is New Year's, and I hope you guys also have a happy New Year. And I will be back in the new year with Season 3, Episode 1 of The Science Behind That. Thank you guys very much for listening. And remember, as always, stand up and question everything.